Thank you. You can hear me, yeah, perfect. So, hello, and first of all, thank you for joining my talk, which will be about the wonderful world of the Windows privilege escalations using potatoes. First of all, you see two names here, myself and Antonio, my friend and partner in crime, because most of the researches that I will discuss today, we did them together. And part of this talk was presented by him last November in Seoul. But I have some news, so it's not the same talk. Oh, why doesn't it work? It worked. Yes. Oh, good, yeah. 2 words about me. I am Andrea Pierini. I am Italian, but I think that's an easy guess just listening to my bad English. I work for Semperis in the Breach Preparedness and Incident Response team as a senior security consultant. Senior because I'm old, because not I'm that expert, but okay, keep on. During my spare time, when I'm not cycling or doing other fun stuff, I like diving into the world of the mysterious world of offensive security. And of course, I am a potato lover. So these are my handles. If you want to get in contact with me or read my blog post, here you have it. Why this talk? In very, very short, we wanted to share our journey in trying to find new potatoes technique. This is what we did, and we spent a lot of time, endless nights, and we used crazy ideas to find always new vulnerabilities in order to exploit what we call the potato technique. So this talk will not go too much in the details, because one, it is boring, and two, it will take too much time. So I will keep it, I hope, interesting and just more simple explanations on, and not going too much deep in the technical details. The agenda, after a brief introduction on what is considered by Microsoft a privilege escalation, so what is a security boundary violation and not, we will delve into the RPC DCOM trigger, which is the trigger which permitted us to find a lot of vulnerabilities via the potato techniques. And after this, we will analyze how it was possible to break the boundaries, the safety boundaries and the security boundaries, local and then also from remote. You see here 3 asterisks. These are the new findings. This is a total new entry. So I will, the first time, talk about this in this session. So I hope you will enjoy it. And then, obviously, at the end, the conclusions. So let's start with what is a privilege escalation. Well, I can say what is not a privilege escalation from Microsoft's point of view. It's not a privilege escalation from admin to kernel or user account control bypass. And it is not a privilege escalation when you abuse a service account or you bypass the Windows service accounts hardening. This is considered a safety boundary, and it is not considered a security violation, alias the behavior is by default or the behavior is as expected, and then sometimes they silently fix, but it's up to them. What is a security boundary violation? Of course, from standard user to admin and the various sandboxes bypasses. So this is my personal consideration. I still don't understand the bounty politics of Microsoft, but probably I'm an old seasoned legacy on-prem guy, so it's difficult for me to understand this decision. I don't know what you think about it, but yeah, that's my personal opinion, and I wanted to share it with you. Okay, where it all began? It began 10 years ago, therefore 10 years of potatoes exploitations, with James Forshaw. You will hear his name several times because he did a lot of fantastic researches, and which helped us very much in our researches too. So we'll hear its name very, very often. And it started with the local NTLM reflection attack, reported in 2014 and fixed in 2015. This was the very, very first, let's say, potato technique, because then the name potato came after, but this is the first, very, very first potato technique. So how does this work? I try to keep it very, very simple. So we have a malicious COM object. Okay, I have the screen here. Perfect. We have this malicious COM object, COM client, which tries to trigger a privileged COM server service. And how does it trigger? Using a special call, a DCOM call, it's co-get instance from my storage, blah, 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 with a class ID. By triggering this COM server service, what happens is that the client crafts a controlled marshaled object, standard ref marshaled object, and this object contains some important informations: the OXID resolver address he should connect to, the OXID resolver port, and this can be controlled by the malicious user. And this is very, very important, because OXID resolution is needed for locating, for the COM server, to locating the binding information on where to contact the COM server. So think about it as a DNS for DCOM, okay? And the other funny thing is that this call is authenticated. So when we trigger this COM server, what happens is that privileged COM server will perform a resolve OXID 2 call, and it is an authenticated call. So we, as a malicious user, can intercept the authentication and then use it. But we can go further. We can also send to the privileged COM server service a string binding containing the information about a fake RPC server under our control, and the COM server, which happily contact us via the IREM unknown interface, two interface call, will contact us, and again, it is an authenticated call. So at the end, we have the possibility to intercept this authentication, and then, depending on the context, we can reflect or relay this authentication. And this is the whole magic. So it's not black magic, but it's a behavior by default. But as usual, there are a lot of behavior by default, which are most of the times ignored. And then when someone discovers it, they can, but this can also be abused. And this is the case. So we have what I call Profit 1 and Profit 2. Remember these two, which has two authentication we can intercept and manipulate. The second one was implemented by us, starting with the RoguePotato tool, I think 3 or 4 years ago. And this is the first time we implemented a rogue OXID resolver so that we could also abuse this second authentication. Okay? So let's start from the very beginning, from service to system, so a safety boundary violation. When I say service, I mean abusing the impersonation privileges, because normally services have at least impersonation privilege. So it's a matter of abusing this privilege. I think that you know this tool? Yes? No? Ah, good, okay. This was the very first implementation. It was done in 2016, and it was the first tool which triggered the DCOM server, and it was somehow limited because it used only the bits CLSID and used the fixed port, which was 666. And basically what it did is trigger the authentication, intercept the authentication, negotiate a system token, and then impersonate the system token. So once you have impersonation privileges, you impersonate the system token, and you are system. And this implementation worked only with Meterpreter, so it was somewhat limited. And then came our JuicyPotato. JuicyPotato, you know it, yeah? Ah, cool. This was coded by me and my friend Giuseppe in 2018, so many years ago. And it was what you call the sugared version of RoguePotato, because it permits you found a lot of other interesting CLSID to abuse. It is possible to specify a port instead of a fixed one. And also, it is standalone. So it used the create process as user or create process with logon token to use the token and then launch a process under the system identity. And it was heavily used because it was very simple to use, and once you compromise the system or an IIS account, an MS SQL service account, it was very easy to perform, a safety boundary violation, okay? This was, let's say, fixed with starting from Windows Server 2019, and with this version, it was no more possible to specify a custom port. And then this fix was backported in 2022, also in Windows 2016. So JuicyPotato stopped working. How was this performed? Without going too much in details, simply by escaping the custom port. Not exactly escaping the custom port, escaping the brackets around the custom port. So once they are escaped, the exploit breaks, and it doesn't work anymore. And so goodbye definitely to JuicyPotato. But obviously, meantime, we had other ideas. So we started with RoguePotato. In RoguePotato, instead of using the local port, and we can no more specify a local port, we used a redirector on a Linux machine, the socket redirector, which then redirects the port that calls from port 135 to a custom port on a service running on our machine. And this service is the fake oxide resolver. What does RoguePotato do? First of all, it uses name pipe instead of TCP/IP, and it creates a custom fake port mapper endpoint. This is very important. The port mapper endpoint is the equivalent, again, of the DNS for RPC. And the trick was, because we cannot create another IP mapper endpoint because it already exists in the name pipes, but the trick was to escape in somehow the checks, so that it is possible to create a port mapper under another, let's say, subdirectory, but because there is a bug, and there is still a bug in converting the /char. As you can see, so if I specify localhost /pipe /blah blah blah, it converts it in a real name pipe path, okay? So once we have the name pipe, it is very easy to impersonate the caller, which is in this case system, okay? Once we have impersonated the caller, we are network service in this case, because the process is the RPSS service. Network service is not that interesting, but in this process, the RPSS service, we have the authentication ID of the RPSS, which permits us to access a lot of Juicy tokens, system code tokens, and whatever. So with a simple token kidnapping, once we have access to the process, we kidnap the token of the system user, and then we authenticate, and then we use this token for creating new processes. This is a simple screenshot on how RoguePotato works. Classic web shell with a CMD. I am the default IIS user, which has impersonation privileges. I launch my tool, and I get back a system shell. So again, a safety boundary violation. With this idea in mind, so intercepting the second authentication and abusing Profit 2, we also rewrote part of JuicyPotato so that it is possible to intercept the second authentication. And meantime, using a trick from James Forshaw, we could also get rid of the socket redirector, because we are no more interested in the first authentication, but in the second authentication, which is returned via the string bindings by our fake oxide resolver. So we are able to intercept this authentication. But sadly, in this case, we don't have that much CLS ID to abuse, because most of them returns you an identification token, which is really useless. There was the print notify service, which was the perfect candidate because it returned an impersonation token. But there was a problem because it needed the interactive seed. So we used the trick to recover the interactive seed, and we were able to perform the full escalation. After some months, Microsoft fixed the possibility to use this trick, but luckily, starting from Windows 11 and Windows Server 2022, we have this other service, the MCP management service, which has its own CLS ID and which permits you again to get an authentication from system with the impersonation token. So it's okay. So basically what we did, we gave, I called it JuicyPotato NG, so we gave a second chance to a JuicyPotato. And this still works, but again, we are always talking about safety boundary violation. So in this screenshot, you can see very, very easy to, once you have an impersonation privilege or an assigned primary token privilege, escalate to system, just launch the tool, and you're done. Obviously, there are a lot of other contributors with a lot of other cool potato techniques. Here are some of them, always safety boundary violations, and there are also other new ones, so it's up to you. But there are a lot of other possibilities to abuse these potato techniques, so I only described the one we found in this case. So let's get it a little bit more interesting. With RoguePotato, with the technique of RoguePotato, so we thought, but is it possible to perform a real privilege escalation? Because we have all the elements. We have to understand how we can abuse the authentication, and if you can get another type of authentication. And here comes RemotePotato Zero, which is the first security boundary violations. In this case, we are relaying the NTLM authentication. It's a local exploit, but the relay is performed on a remote server. And what does the RemotePotato do? It abuses some COM servers which impersonates the logged in user. And this is interesting because the idea is intercept the authentication of the user connected on another session and relay the authentication to an external server. So imagine that if you have an admin or whatever user which other privilege is connected, I can trigger his authentication and forward the authentication via NTLM to a target server where I want to access resources on behalf of this user. We had the problem because by default signing was enabled, so this limits somehow. But with another trick, we were able to downgrade to RPC level connect, which means then signing is no more enabled via the resolve OXID 2 call. So the main scenario is obviously when you have a privileged user in a multi-user environment. Imagine a desktop, remote desktop, a privileged user. I trigger his authentication and I relay it to LDAP. Imagine a domain admin. I know that domain admin should never log on non-tier 0, but who knows? Maybe it could be possible. So you can relay it, and at this point, you relay the authentication, and depending on the user who you are relaying, you can take over the domain. So in this screenshot, it's just an example. We have the standard user 13, and domain admin user, which is connected on another session. I launched the RemotePotato Zero tool, specifying the session, and then I forward. I am able to intercept the NTLM v2 hashes. I forward the NTLM v2 hashes to an external relay, for example, NTLM relay, and then I can do whatever I want. What we did in RemotePotato is also to make perform before a local relay from DCOM to HTTP, so that it is more easy to interface with external relay tools, just like, for example, NTRM relay. We obviously reported this to Microsoft before publishing it, because for us it's a security boundary violation. And what Microsoft said, after a long debate, a long analysis, and so on, that server must defend themselves against relay attacks. And for this occasion, we created a special T-shirt for this. So sadly, I forgot it because I wanted to show you this T-shirt, but I left it at home. So, but 18 months later, kind of unintended fix broke RemotePotato because it was no more possible to control the signing. So it is always signed. So the relay versus LDAP, for example, won't work anymore. But it still works where SMB signing is not required. For example, SMB, HTTP, SMB signing is not required, but normally the default is on domain controller, yes, but on file server and so on, we leave the default, which is not signed. So you can do, a malicious actor can do a lot of nasty things, still can do a lot of nasty things with RemotePotato Zero. So move on LocalPotato. This is a curious story because it's kind of, I wouldn't call it a bug, but it's, again, it's by design. In the local and telemetry authentication, so we are again speaking about local and authentication is a particular authentication, it's a loopback local authentication. There is a reserved field which is called reserved field that is very interesting. And thanks to our friend Ilad Shamir, which gave us this hint, we tried to understand if it is possible somehow to abuse this field, because we had in mind a kind of swapping, and this is what we did. So in the local authentication, the reserved fields references the LSAS context where the user should, where the authentication should occur, okay? Associate and occur. So the idea is, why not triggering the authentication of a privileged user or a system account, swap the context with the user under our control, and then authenticate to another server as the system, to another service running on the same machine, because it's always a local privilege escalation. And that was what we had in mind. So first of all, we trigger a system authentication, and we know how to do it. We want to target, for example, the local SMB server and perform an arbitrary file write with system privileges, which is really the key to the kingdom. We had to overcome some anti-reflection mechanisms, so we have to specify an SPN. And once everything is set up, we intercept this authentication, we magically swap them, and then what should happen, that we are able to authenticate as a system to the SMB server. And then once you have an arbitrary file write, it's up to you to understand how you could abuse it. For example, we hijacked the DLL in the printconfig.dll in the printer service, and we were able to use our malicious DLL to get a shell, for example, as a system. So how does this work? We have, first of all, our privileged client, and we trigger the authentication of our privileged client, and we associate it with context, let's say, A. Then we have also client process under our control, which tries to authenticate versus the server service, for example, the SMB server, and our client gets back the context P. Then we swap the contexts so that the server, the privileged client will associate with context B, and our client context with the context A. And at the end, if everything works fine, the privileged client will authenticate against the server service SMB in this case, and the client process will authenticate against our server service. Okay, I have also a video demonstrating this. You see, I have here, it's running, okay, a standard user without particular privileges, and my goal is to overwrite the print config DLL. Okay, I get no output here. Something strange happening. No. Okay. Let's do it another way. Okay. It's not easy now, but sorry. Okay, we skip the video for now and then we'll see. So, extend this display. Okay. It's frozen. Sorry, but it's more than the demo effect. That's it's always Windows, no problem. Okay. Something that's not working because I still, okay, without showing the video, but here you get it. I'm able, with our LocalPotato exploit, to overwrite the DLL, then I instantiate the object, and I get back a system shell, because in my DLL I put the instruction for returning a shell. That's all. That's clearly, no problem. That's clearly a privilege escalation, obviously, and if I can get out of this video. And clearly Microsoft fixed it with this CVE. And what it did, what Microsoft did is that this is the reverse engineering of the fix which was done in this DLL. If the caller is from an unverified source, and this flag is set by the TCOM client, and if the SPN set is set, the SPN is deleted, so the anti-reflection mechanism won't work, will work, because I have no SPN, and the exploit breaks. So, but it still works against HTTP. WebDAV is a very, very edge case, but it still works. Or versus custom authentication, which uses the security provider. Okay, so, and Microsoft did not want to fix the second one because we reported already the second one. They said no, but this is too complicated, so it's an edge case, so you have to protect your endpoint, you have to use extended protection, blah, 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 and it is not fixed. So if you go on my blog post, I think I published also the latest LocalPotato source code is also for HTTP, so you can try it at home and see that it still works. Then comes FakePotato. FakePotato is the one with the asterisk because it was discovered by me 3 months ago, let's say so. And it's a local privilege escalation. Still waiting for Microsoft fix, so unfortunately I cannot spoil that much. It's not exactly a potato technique, so it's something a little bit different. And it's cool because its logic pack, I think it was there from Windows 2000. So it's something that I don't know why it was never found. And because it requires an unexpected prerequisite, but which is not that strange. So, and when I discovered this, no, it's not possible. Somewhere, it's something that fucked up on my machine. And Microsoft confirmed that it is a security boundary violation, so it has to be fixed. I have a video. I don't know, I pray the God, but before showing you the video, I obviously asked to Microsoft, and they told me, okay, send us the video in order to avoid the usual drama. So send us the video, and we will tell you if it's okay or not. And you can see the mail. They told me, okay, you can show the video, but do not spoil other things. So I will only show you the video, and I won't talk. Will it work now? Ha. That's a good question. Okay. Oh, okay, great. Oh, okay. In the first, I have an administrator connected on a session. Another session, I have another user, standard user, okay? You see 2 sessions. Now I launch my FakePotato tool against the admin session, and let's see what's happened. Oops. Desktop changed. But, okay. Let's get more serious, okay? So I relaunched the tool with another mode, okay? And let's see what happens. I get back a shell of the administrator. This is clearly a privilege escalation. But don't ask me anything, please. Okay? So now the last one, which is the security boundary evaluation from remote. So the idea behind is very simple. Instead of triggering a local com server, why not triggering a remote com server? It would be a great remote local privilege escalation, okay? In fact, obviously an external Oxid resolver is required in this case for the first authentication. It's very, very simple because with just a few changes on the code by specifying the remote server and optional credentials, I should trigger the authentication of remote server because it's in the library. I can specify or the local or the remote server. So that would be great because once I have captured the authentication, NTLM, Kerberos, I could then relay it. And this is also a great opportunity for Kerberos because I forgot to say you that it is possible to relay Kerberos authentication under certain conditions. If you have the control of the service principal name, you can perform a Kerberos relay. And this is the perfect scenario because I am able, in my fake Oxid resolver, to specify the SPN, and so I can relay also the Kerberos authentication. But there is a great but. Non-admin users generally cannot instantiate remote objects. So to instantiate, to create a CoGet instance on remote, you need domain admin or local admin rights. So any chance? So I started looking at the DCOM configurations and so on in order to find vulnerable DCOM server. And the first one I found I called it ADCSCoercePotato, which is related to the certification service. So on a server where the certificate, the ADCS services are installed, there is there is this group, the certificate DCOM access groups, which contains the authenticated users, everyone, okay? This is needed because users or computers should be able to request and enroll certificates via DCOM. So this is clearly something by default. So users can activate and these applications from remote, as you can see. The certificate DCOM services have local and remote activation. The certification service DCOM application impersonates the system account, so via the network it's the computer account, and is activable by everyone, every authenticated user. So what is the idea behind? Very, very simple again. It's just activating this object via the potato technique, that we will coerce the authentication of the server, and we will relay this authentication. So what can we do with when we have the authentication of the certificate server? I think we can do a lot of cool things because this is a tier 0 computer account. This one was discovered also before me, some time before, by another Chinese researcher. Unfortunately, I'm horrible in spelling, so I just said Chinese researchers, and was partially fixed with this CVA. As you can see, it's also, again, the concept is always the same. I have a standard user. I coerce the authentication. The first IP is the IP address of the certification service. Okay, and then I have my redirector, and where also NTLM relay is running. Okay, I pass my credentials, and as you can see, everything was fine. This is the dump of the NTLM messages, and at the end, I get the authentication of the certificate server. Okay, so what can I do now? Relay it. We have a problem because signing is now enabled, so we cannot relay versus LDAP or whatever. And we could relay against the HTTP web enroll service because we would then request a certificate of the ADCS server. And as you can imagine, if I have the client, the certificate for authenticating as the certificate server service, I'm done because I can perform code execution on the certificate server machine, back up the public and the private key, forge fake certificates for whatever user I want, and I can take over the domain. But unfortunately, NTLM, you cannot relay back NTLM authentication. So I cannot relay back the authentication to the certificate server itself. So yeah, it's really limited. But wait. There is a great opportunity with Kerberos, because with Kerberos, you can relay back via HTTP. So the server can relay back the authentication to itself via the network if I use HTTP. And this is interesting because if I don't have extended protection enabled or I do not require SSL, I can request a certificate. And this is the screenshot with my modified version of the great Kerberos relay tool, where I target the web enrollment service. My DCOM host is, again, the ADCS web server, so I trigger the authentication, relay it back, request a certificate, and obtain the certificate for client authentication of the certificate server. And I'm done. So yeah, and therefore, we should always use extended protection, blah, 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 because this still works. So you know, if you don't use these countermeasures, you are at your own risk. But I didn't stop here, because digging further into the DCOM, I found these two groups. I call them the forgotten groups, and this led me to SilverPotato. we have these two groups, which are built in, I could say, not so well-known groups, which are the distributed COM users group and the performance COM users groups. From Microsoft description, we understand they can somehow interact with the DCOM server, and that is interesting. So members of these two groups can launch and activate DCOM services from local and remote. So not only activate, because activate means that the service needs to be running, and launch means that I can start the service from remote. So the performance local users group and distributed COM users group can do these things. This is cool. Now we have to find a service which can be launched, activated by these users, and which has an authentication which could be useful for us. And I found this object, the SPPUI object interactive class. It's related to the Windows license service, which is the perfect candidate because it runs as the interactive user, and it can be activated and launched by everyone. That does not mean that it's by everyone, because then you have the limits by the DCOM and the members of the DCOM or performance locked user groups. So this is a very, very interesting scenario. So by triggering this service, we should get back the interactive back the authentication of the interactive user connected on some session. Okay? If you are a member of these groups, you are a member of this group, it's not correct to call them domain, but on the domain controllers built-in group, you can imagine that this could be very, very, very dangerous, because normally on a domain controller, the domain admin logs in. So if you could trigger the authentication of the domain admin, well, that's interesting. So how does this work? We have an attacker, which is member of distributed COM users or performance log users group. And then we have a victim connected on a domain controller. So again, with the potato technique, I trigger the authentication with the CLS ID of the SPPUI service, and which triggers the victim connected on a session to authenticate to my endpoint. Because, as we saw, we will perform an authenticated resolve OXID call. We are able to intercept this authentication, in this case from the domain admin, and use it. We can also return a string binding, which contains the port and an optional SPN of our fake RPC server. And we have another authenticate call, and we have the second profit. So I did this, I tested this, and for the first one, it's okay. We have NTLM, I was able to perform an NTLM relay attack with an impersonation level, which is what we need. In the second one, sadly, you have an identification level, which is really useless because signing is enabled, so you can even relay versus LDAP. I obviously reported this to Microsoft before, and after, initially they said it was a critical finding, but then after some time, they assess it as a moderate risk, and that does not need an immediate servicing. So I can talk about this, okay? But, okay, I have the video, finger crossed. It works, great. So I have my user, standard user, member of this, let's say, domain, DCOM, distributed COM users group. On the other, then I am here in the worst scenario because I have NTLM v1 enabled. So in NTLM, I will remove the message integrity check and disable signing, okay? I launch my tool where I specify the domain controller address, again, my redirector and the host where NTLM relay is running, and the session, okay? Once I launch it, as you can see, at the end, I am able to get the authentication from administrator. I will forward the authentication to NTLM relay, which will forward it to LDAP. Which will create a user account with DC sync rights. So from a standard user, I took over the domain. That's something that I don't know why they did. They said, no, it's not that. Because in my job, because this is a hobby, in my job I do active directory assessment. And I found it at least 2 or 3 times that this group was populated by non-tier 0 users. So therefore, we should consider these 2 groups absolutely tier 0 until Microsoft decides to fix something. This works also on a local group, on a local server, but obviously the domain controller is much more interesting. Okay? So the next step was Kerberos. Okay, NTLM, I can relay NTLM. Why not relaying Kerberos? Well, here we have 2 problems. The first one is that the original Kerberos relay tool, which is a great tool, only intercepts the first authentication, the second authentication. And the second prerequisite for performing Kerberos relay is that you have to control the SPN. So for the first problem, I recoded Kerberos relay. It was really a long, tedious, and boring task because I had to implement a raw socket server, intercept the authentication, extract the Kerberos, and then move back and forth between DCOM and SMB. It was really, I was giving up several times, but at the end, I was able to get it working. And then we have the second one, SPN. Sadly, in the first authentication, when we return the string bindings, even if you return an SPN, the SPN will always be RPCSS / the server where our socket redirector is listening, because it's from where it's coming from. So no chance. Then again, thanks to a trick from James Forshaw, we can bypass these SPN limitations by adding a forged DNS name, okay? Because the Kerberos security provider extensions supports a special format for the SPN, which includes the target info. So it's the syntax is the following: service class / server, which is the classic SPN, plus the base 64 encoded target information. And Kerberos will ask for a service ticket service server class, server, and the offset resolver will try to contact a server which is server plus the base 64 address. And the shortest base 64 target info address is this one, which corresponds to a completely empty target information, but the security provider will happily accept it. So what I did is add the DNS record with this strange name, because normally standard domain user can perform secure DNS updates, and then relay the application request ticket to a target server on behalf of the user, in this case, the domain admin. Again, this is the scenario: user, member of these groups, victim connecting domain controller, and the target server where I want to access resources on behalf of the victim. So what happens? Again, I perform, I trigger the authentication, and then in the socket address, I specify this name because I created this DNS name. The victim will ask for a service ticket RPSS / target. It will try to authenticate against me with this application request ticket. The attacker will simply forward this ticket to the destination server, and relay is successful. So just to demonstrate to you that it does not only work on PowerPoint, I have another demo. Okay. Oh, it works, great. So I create IDCS -mylab is my IDCS server, okay? And this is the, okay, sorry. Okay. So With invoke DNS update tool, I create this DNS record. Okay, now I have it. I capture the traffic just to show you that it is what it was expected. I launch my Kerberos SilverPotato tool, targeting, in this case, I want to target the SMB server of the IDCS server, okay, with this strange redirect host. And as you can see, I want to dump the local SAM account database, and I was able to dump the admin hash, okay? And as you can see, the SPN is the one we expected. And this is all the traffic for the remote registry access, dumping the SAM database, etc. Once you have, again, the hash of the local administrator, you can log on, okay? Again, perform backup of the private key, elevate to system, perform the backup of private key, etc., and you're done. So you have, again, another possibility. So we are at the conclusion. Okay, perfect. What can I say? First of all, that with potatoes, we break safety and security boundaries, okay? Most MS fixes were already partial or even not implemented because it's by default. Future NTLM disablement will stop some relay attacks, but remember that if you have control over SPN, you can relay Kerberos. The question is, will potatoes be still alive and kicking? Who knows? Maybe we should find a potato in the cloud, but it's not for me. So, second conclusion for the defenders. So, because many of these attack paths at the end lead to relaying the authentication. So, Microsoft always tells us you have to disable NTM because it's dangerous, etc., etc., etc. But as we can see, Kerberos can be relayed too. So the only way is to protect our endpoints. So I hope you enjoyed my talk. Sadly, I had some problems, and thank you.
Thank you very, very much for this interesting talk. And I guess there will be questions in the, yeah, back there.
Thank you. So some of the attacks which you were talking about were using the web dev or web client service, and of course one of the countermeasures would be to disable this service. Have you seen any dependencies on this service? Like what could go wrong if you disable it?
Okay, probably the only attack I performed via LocalPotato Expert via WebDAV was with LocalPotato to demonstrate that via HTTP it was not fixed. Obviously, it's an edge case via HTTP. So I configured a WebDAV server in order to have an arbitrary write via WebDAV HTTP. So this is, it's not, the other attacks have nothing to do with WebDAV. It's versus SMB or whatever, or versus the web enrollment service. This is just to show that there is still a possibility. Imagine that you have a web application, but you have you need to have local access, and then you are able to authenticate on this web application as system account. So depending on how it is configured, you could do nasty things, but it's really an edge case.
Mm-hmm. Okay, thanks. But still, have you seen any dependencies on the WebDAV service, WebDAV client, like any Windows component or third-party application actually using it, requiring it?
No, to be honest, no.
Thanks, and
but
thanks.
Maybe it's just limited to my experience, so I don't know.
Thanks for a great talk.
Are there any other questions? Okay, then, thank you again.
Or it was too complicated, or it was really easy, so no question. I go for the second one. Thank you.